Hey everybody, welcome back to 30 Days of Python. Today is day 8. We are diving into the most practical and powerful data structure in Python, which is dictionaries. Let's get into this. So let's get into dictionaries. We finally went through all of the lists, tuples, and sets in the previous days, and we finally reached dictionaries, which are unordered changeable collection of key value pairs. What does that mean exactly? So let's look at it in this and break it down. So key value pairs, which is pieces of data that has a label and the actual data is its value. We know it's unordered very much the same way sets are set up, and it's changeable, which means you can add, remove and modify it. The keys must be immutable or unchangeable, so strings, numbers and tuples are fine in this regard. So in order to create a dictionary, we're looking at the curly braces to create an empty dictionary, and to fill out a dictionary you are adding it in as categories, like in this example. The variable person will be a variable for this dictionary. As you can see, it specifies it into a small category like first name, last name, the age, and a boolean check is a developer is there. So using a dictionary would entail just specifying dict with the open parentheses. So in this example, person 2, and you specify dict open with the name assigned to Alice, the age assigning 25, which is the age of Alice, and the city, which is coming from a string variable, which is New York. And then you can print them both out, and you can access the values of what you are printing out. So for this example, if you're printing out person and specifying the first name, the output should be John. Think of dictionaries like a real dictionary. You look up a word, the key, and get the definition, the value, or like a form, the name, the age, and the email. Each field has a label and the actual data. So let's dive right into it. The beauty is in how intuitive the operations are. So starting off the dictionary, we assign it to the variable person. The name will be John, the age 30, and the city is New York. So we have the labels name, age, and city. Accessing the values, you print out the person and you specify the label, and the output should be the value John. You cannot print out the person and then say the label country, because there is no value as country assigned to it, and there's no label as country in the dictionary itself. You can only call the label or the value from the dictionary that exists inside the dictionary. Very much like the list and tuple and set. You can't call the value or the label or the index from that set or list or tuple if it doesn't exist. If something doesn't exist and you call the value, it cannot be retrieved. So a safer access with the get function. So you print the person and then you say .get and the country. It will return none, but not an error, because you can't. It will be a blank space in the console and it will return with no error. Whereas if you were to access it and specify the label within the dictionary, that will be an error. So another way is to say .get country and you specify USA, it will be a default name. It will actually return USA to you as something that's maybe in the dictionary, but it specifies that you can add it in as well. So adding and modifying, as you see here, you call in the variable person and open brackets, the block brackets or square brackets. You adding in email, you're adding the label email and you're assigning a value to it. And the same here, the person's age, you open brackets or square brackets, call upon the label and assign a value to it. That's modifying something that already exists, as you can see in this example. And then if you print it out, you should either see an additional label in the dictionary as email, and you should see an additional update to the label age. Removing an element in the variable email, you call upon the dictionary and you say pop and you specify the label, and you should end up seeing that the dictionary has removed the email label altogether. The delete person and specifying the city, which will be New York, will be removed without returning anything. The whole function of the whole line of code will just return nothing. And then when you print out or call the dictionary person, you should end up seeing that the label is removed as well. And the function clear will clear out the entire dictionary altogether and empty the dictionary. The get open parentheses method is your best friend when working with dictionaries. It prevents your program from crashing when you get a key that doesn't exist inside the dictionary. So Python does have a set of methods that works with dictionaries. Let's see how. In this example, again, we have the variable person assigned to it is a dictionary, labels name, age, city, and a boolean check. So getting keys, values, and items. When you print out the dictionary and the keys function, utilizing the key function, you should end up getting the labels given back to you in a list form. It will, as the comment suggests, it will come back as dictionary keys with name, age, city, and is a developer in the console. If you print out the values, it will return the exact same format, just with all the values that are placed in for the keys. You should return Alice, the integer of 25, Boston, and the boolean true. If you utilize the items function, you should get the collection together as in name, comma Alice as well. So it will be the label, the key, and the value in one bracket, and then the age and the integer for the age in one bracket. Looking at looping through dictionary, for for loop, we can use for key in the dictionary naming, which is person. The function inside this for loop can either print out the key and the person, the key variable, and it should output the value of that key inside that is inside the dictionary. Checking for existence, as in the in function. So name, checking the label name is inside the dictionary person, it will return true. Country will obviously return false as it doesn't exist. So utilizing the update function, updating a dictionary involves calling upon the dictionary dot update. Inside the parentheses, you specify with this curly braces the label and the value to that label that you're going to update. And if you're adding in, and in the same sense you can add, so you're adding in the country and the string value to that label as well if you are doing this. And when you print it out, the age and the country should have been updated or added in. So notice that items gives you both key and value together. This is the most Pythonic way to loop through a dictionary. As you can see, in a better way to loop through items, other than looping through the entire dictionary, you can call upon it by using the for loop key and calling the value. So you're looking for the key and the value inside the person dictionary, and you're saying dot items to get all together, and it will loop through each row together. Now let's look at some real world problems. This is where they become absolutely useful and essential to your everyday programming. In this example here, we can see the first one talks about configuration settings. So app config, and I've seen this many times in terms of looking through setting code for games and things, right? You will always see an app config, and here you can see inside the curly braces you have the labels debug, database URL, the port, and allowed hosts, and with each value corresponding to that. So the debug will be a boolean, the port will have an integer value, and the allowed hosts is somewhat of its own sort of dictionary in its sense as well, but it's not a dictionary itself. It's not a dictionary inside a dictionary. It's a list format. So there's localhost, and then the value to that will be the IP address. So, and then the second use case is user profiles. In this dictionary, you can see the username, the email, and then inside is another dictionary called preferences, and this label has labels inside of it as well. So dictionary inside a dictionary, and that has the 3 labels of theme, language, and notification with its values there as well. And then it has the list as seen before in the first example of configurations. This has another list of user 1, user 2, user 3 with the label friends. The next use case is counting word frequencies. So the text has words in them. So apple, banana, apple, orange, banana, apple. So apple and banana is a duplicate inside the string variable. So another variable words is then used, and you can split it up with spaces, and then you can do a word count with the empty dictionary. In the loop, you can then call in the variable word in the variable words. So word in words, the word.count, you can specify that into calling upon the word variable that you specified in the conditions of the for loop. Assign word underscore count dot get function, specify the word and specify the variable word and the value to that +1. So if you print out the word count, the apple should display 3, banana 2, and orange 1. The next is API responses. So this is JSON. JSON is basically a dictionary, right? These are JSON is very useful in database structures in SQL and large database systems and servers. So the API response will be the labels of status, and then a dictionary of a list or a tuple, which will have users as it holds a dictionary as well. As you can see there, it will be ID and name, and then inside the data dictionary will be a total count. So you see how dictionaries are naturally represented in real world data. This is why they used everywhere in web APIs, configuration files, and data processing. Now let's go one step further in the concept of a dictionary. These are nested dictionaries, as we've seen in the previous example. So in this example, we can see nested dictionaries representing complex data. So in this dictionary example of company, we have a name of the company as its value. We have a nested dictionary, which is employees, and inside that is another dictionary, CEOs. So think of this as like on a website, it has a drop down tab, and inside that tab there's another list of items that you can view, and that's basically what is happening here. So this will be the employees of the company drop down tab, and then you'll see CEO, developer, and departments. And if you click on CEO, you'll have another drop down tab with a name and the salary. And if you click on developers drop down tab, you'll have the name and salary as well. And then inside, and then the department will also be to have a drop down menu as well. So think of it in that sense, that it's different tabs on a website. So the labels here is employee, and then inside that tab will be the label CEO, and inside that will be the name, and you can click on the name and it should display Alice as its value. Salary is another label inside the CEO tab, and the value should be an integer of whatever they should be, in this case 200,000. And in the same cases for developer and department, but the department is showing a list of a string data types rather than another dictionary. So accessing nested data, you want to print out the company out. The company is the dictionary, so the dictionary company, and in square brackets you want to print out the employees, and specify the label CEO and the name. So what this is basically doing is looking at the label employees and looking at inside like I said before, it's drop down tab. You then look at what other labels are inside this drop down tab of employees, and you then clicking on CEO as the next drop down tab, and inside that drop down tab you're looking at the name, and it should output Alice Smith as seen in the dictionary above. The dictionary comprehension, it's like list comprehensions. So you have a list, numbers in order of 1, 2, 3, 4, 5. You have variable squares, which will then square root everything in that. But in this case, when you print out, as you can see in the squares, we've put it into a bracket, into a curly braces. The X would now represent every value of the list. So when you print out squares, you should see 1 with the square root of 1, 2 with the square root of 2, which is 4, and 3 square root of 3, which is 9, and so on and so forth. With conditions, the even squares variable is assigned again like the squares dictionary variable. Square rooted it, and for x in numbers, if x modulo 2 returns 0. So if the remainder is 0 when you do the when you run the operator of modulo 2, you should end up only outputting the values that have a remainder of 0 when divided by 2. So in this case, it will be the second x value, which is 2, and the fourth value, which is 4. So creating from two lists, if you have two lists, how do you create a dictionary from that? You then have, in this example, the list keys and values, and the dictionary person. You can then say K, which will represent the keys. V is your general variable inside the for loop. V for K, V in zip keys value. The zip would essentially combine the two lists together. It's a function that combines the two lists together in a single line. And when you print out the dictionary person, you should end up the same way with a normal dictionary type, split, and it's split by commas. The dictionary comprehensions are elegant and very efficient. They let you create dictionaries in a single readable line. Now there are special dictionary types within Python in the collection module that are very useful. This is what they are. In this example, you can see from collections, import default dict and counter. Default dict is something that automatically handles missing keys. Okay, so in this case, we have a word count assigned default dictionary integer. So in the list words, you can see that apple appears twice, banana once, and orange once. So in the for loop, for word in the list words, you can use the word count and specify the variable word to be added on. So in this case, you can look at it as for every word that is in this list, count +1, and then the output should be in a dictionary format of the label apple and the word count as its value. The counter is built for counting, so we have a words variable in a list format, and you can see that apple is twice, banana is twice, apple is thrice, banana is counted twice, and apple is counted 3 times. So word counter, the counter function, and you specify the list that you're counting, and you can print out word counter, and it will output as counter and the dictionary, and in the dictionary format the amount of words there are. You can go further and use the most common function of 2, and you can basically specify which word is being counted twice or more than twice, given your specification of integer value that you're looking at. So most common of 2 times will be apple, which is 3, and banana, which is 2. The set default function is the most useful method. So the dictionary person has a label of name and age, and if you use a set default on the city and you give a value of unknown, this only sets if key doesn't exist, and if you print it out, it will add the value or the label city and the value of unknown to the dictionary. These are specialized dictionaries that can save you a ton of code and make all your logic a lot cleaner. So here are some common errors that we all run into from time to time, and that is lists that are mutable being placed inside the dictionary. So using changeable objects as keys, for example, like in this example 1 and 2 in a list, and then you add the value in place of the keys. So a valid dictionary with this regard would be you have your dictionary in your curly braces, and then open parentheses, the curve braces, and then 1, 2, and then the value. So because tuples are fine, the curve braces are tuples, the square braces, the square brackets are lists. Another pitfall will be assuming order in all the Python versions. It's not a big deal, but it's sometimes when you don't update your Python libraries that will happen. The other one is assessing non-existent keys directly. This will be like, for example, in the dictionary a key doesn't exist, like countries, or in this case age. It doesn't exist, it's not specified, right? But you can use the get function to specify the key and then the value of not specified, and that's actually a safer way to get keys that aren't existing inside the dictionary. The last example of gotchas or pitfalls in errors of coding is modifying dictionaries while iterating. If you need to modify something, it is better to copy it very much the same way tuples are done. If you need to copy a tuple, iterate through a tuple, copy a tuple and iterate through the copy instead of iterating the original version of the dictionary as well. Hope today's lesson was helpful for you, and I hope that the progress within the 30-day Python challenge is going well. I will see you tomorrow. Thank you and goodbye.